On number 9, notice that it says 5 members, but it's written in words, so be real careful with that. 5 members of the Math Club are raising money for an out-of-town competition. Cost to attend the competition is $75 per participant. Per means multiply. At a bake sale, the Math Club raised $225 by selling 300 baked goods. If the amount raised varies directly, so again, that means it's proportional with the baked goods sold, how many more baked goods do we need to sell for the rest of the money? So that means we're going to subtract. So there's a lot of operations happening here. First of all, if it's $75 per participant and we have 5 participants, that means we need $375. Okay? Then we know they vary directly. The amount raised varies directly. So here's the amount raised. That's our Y. Versus baked goods is X. So Y over X. And we need to raise, and if we put some labels on here, $225, 300 baked goods, and we need $375. So again, we're making a proportion. We're going to cross multiply here. 375 times 300 divided by 225 is 500. So we need to sell 500 baked goods, but that is not our answer because we've already sold 300. We need to sell 500. So now we have to subtract 500 baked goods minus 300 baked goods means we need to sell 200 more. Okay, so lots and lots of words to tell you the operations to do there. Read real carefully to make sure you do all of the operations. Number 10 says, Laura wears a GPS watch. When she runs, keep track of her pace. Scatter plot shows the number of miles she runs per minute. What conclusion is best supported? So we're looking at this. We can see the lines tend to go, the dots tend to go up. So this is in fact a positive correlation, which means that it's going both variables are going up or both variables are going down. So let's read. As her distance increases, her pace increases. This is up, up. As her distance increases, her pace remains the same. Okay, so or constant. Her distance increases, her pace decreases, or there's no relationship. Well, we already said it's positive, so up, up, the answer is A. Beth does an inventory of shoes remaining at the end of the day at her store where she works. She makes a scatter plot showing the size of the shoe and the number of pairs. Which statement best supports this? So you can see there's not really anything going on. This is very non-linear. This is going to be no correlation. So as the shoe size increases, the number of pairs of shoes increases? No. As the shoe increases, number of shoe sizes decreases? No. The shoe size increases, the number of pairs stays the same? No. Or there is no relationship. No correlation is going to be no relationship. Juan's mom gives him $10 a week to take out the trash when he comes home from school. He wants to buy a $50 video game. He decides to start saving 40%. Which of the following unit rates would describe the slope of the graph of Juan's savings? So, how much, essentially what we're asking is, how much does he save per week? Okay? So this $50 video game is not part of this. We don't care about that. That's not what it's asking. It's just asking about savings. So if he saves $10 every 1 week, and we need to multiply that by 40% or 40 over 100, you can do it this way, or you can say 10 times 0.4. Either way, you can use your calculator. 10 times 0.4. We change our percent to a decimal is $4. Saved per 1 week, which is going to be B. If you did it as a fraction, top times top, bottom times bottom. 400 over 100 is still 4. Alright? These are going to have the same scale when we look at these graphs of strawberries in cost and bananas in cost. Which statement is true? Notice that this number for strawberries, line for strawberries, this is steeper. So that means that it's going to have a higher unit rate. This one is flatter, or not as steep, so this is going to be a lower unit rate. So when we look at our choices, the cost of each banana is more expensive than the cost of strawberries? No. If it has a lower unit rate, that means it's cheaper. They cost the same? No, because the lines don't match. The cost of the strawberry is more expensive than the cost of bananas? Yes. The relationship cannot be determined? No. So this one was going to be C. Alright, last page. Scatter plots. If the trend shown in the graph continues, how many tickets will be sold after 10 hours? So you can do a couple of things. We can extend this line. And we know that this 10 would be here. So if you remember when we talked about this, we said you have to go up to your trend line and over. And that y-axis is counting by 5, so this would be 50 tickets. Here, Marty continues to walk at the same rate. How far will he walk in 3.1 hours? Well, 3.1 is here. So we can try to extend this line. And we can go up. And we can go over. Now, when we do that, we can kind of estimate where we would be at. We know this is 10, right? So maybe this is 11. So maybe this is 12. So that looks like it's just above 12, which is a possibility here, which would be C. Now we can also write an equation of the line. We've practiced that. We can count. This is proportional. So the B is 0. We can count the slope. We can count rise over run. Because we have 2 dots right here. So pay attention to your scale. So 1, 2, 3, 4, 5, 6. And 1, now this is counting by half, so be careful. So this is a half, a whole, and 1 1/2. So our slope is 6 over 1 1/2, which, looking at my calculator, 6 divided by 1 1/2 is in fact 4. So our slope would be 4 miles over 1 hour. So we can write our equation, y equals 4x, and we can plug in our number of hours. 4 times 3.1 is in fact 12.4. And the last one, we can draw our trend line. Okay, 3 different skateboards created a scatter plot and their selling price. So what is the price in 2017? So again, we can kind of estimate this. We can go up and over. It's between 50 and 60. And there's not a number. The closest one would be 60. Or you can also write an equation again. Please let me know if you have any questions.